Hi, so this is my Proccess Journal entry for September the 8th, 2014. I decided to make this entry using video format. The reason for this is because I felt like there needed to be a lot of explaining, and I don't think what I could write with text would be sufficient since there are a lot of visuals and a lot of images that need explaining. So I'm gonna start off from everything I have done with my product as of September the 8th. Um, so this my the first two lines of code are this process globals sub, which basically means they can be accessed through any part of the program. So the first thing I've defined is this variable called chessboard, which is a two-dimensional array with boundaries being 8 by 8. When its boundary is 8, basically it means you can hold 0 to 7 values and 0 to 7 values, which is including 0. So it'll be 0, 1, 2, 3, 4, 5, 6, 7, and that's it. So it can hold a total of 8 values since we're also counting 0. So it'll be 0 to 7, comma 0 to 7, and it'll be an integer. So what this basically looks like is basically two sets of numbers, 0 to 7, 0 to 7, and each set can hold a value. For example, 0, 0 can hold 2, 0, 1, 0 can hold 3, and this goes in length and then width. So the first set is length and the second set is width in my program. Then I also define this other two-dimensional array called moves. You'll understand why I define this array in later in the video. So this next sub is activity create, the activity underscore create sub, which basically means as soon as the activity is created, which as soon as the program is started, it'll do all these commands. So the first thing is load layout chessboard, which is basically this layout is just a plain layout with a list view. This is not going to be the actual layout of my actual program. The reason I'm using a list view is because I just need to test whether my application works and output values and see if they're correct. The second thing I do is dim I as an integer which equals 0 and dim j as an integer which equals 0. Don't worry about this right now. So this function here that I created basically sets every single value in the two-dimensional array chessboard as 0. So it'll set 0 0 as 0 as the value 0, 0 1 0 as the value 0. Basically this whole chessboard as the value 0. The way in which it does this is since we've already defined two integers which equals 0, I is equal to 0 and j is equal to 0, it'll start off with chessboard 0 0 equals 0, and then which is basically this chessboard 0 0 equals 0, and then it'll do j plus 1, so which is this j plus 1 since j is width, and then it'll loop and it'll do it until j is equal to 7. So it'll j plus 1 and then that chessboard ij, which is j is equal to 1 now, is equal to 0, then it'll plus 1 again, so j will be equal to 2. So slowly fill out this whole column until j is equal to 0, and that will be the last instance in which it does it. And then after that's done, it will go into the second loop, which is do until I is equal to 7. And then what that basically does is sets j back to 0 again, and then it just adds 1 to I. So it'll just, after it's j is equal to 7, and it goes to the next, there is no next, so until j is equal to 7, then it'll go I plus 1 and it'll set j back to 0. So it'll slowly fill out this whole array to become 0. The next thing I did here, although it's commented out, is I set the chessboard as different values. So for example, I set a chessboard 1 0 to 1. So in my application, I have values to represent different pieces. For example, 1 uh, represents the pawn, 4 represents the rook, 3 represents the knight, 2 represents the bishop, 5 represents the queen, and 9 represents the king. So when I say chessboard 1 0 is equal to 1, chessboard 1 0 1 0, since it's length and then width, 1 0 is equal to 1, so it's a pawn. And then I'm going to say 1 1 1 2. So basically it's going to set this whole row into being pawns, and then it's going to set the other pieces respectively on both sides. The values of the pieces on the opponent sides are just the same value, but a negative. So when I say pawn is 1, the pawn on the other side will be -1. It's just an easy way of identifying which pieces are which, but also what piece is what. The reason I commented this out is in order to test if my program properly works, I need to have a sample chessboard which is just mixed with different pieces in different places, so I can see whether the program is working or not. So this current chessboard layout is the same chessboard layout you see in this image. For example, there's a rook, a castle at 0 and 0 3, and as you can see here, since castle is 4, there's a castle at 0 and 0 3. So basically this set of values represents this board here, just in order to check whether my values the values make sense and work. So the next thing, actually I don't need this anymore, but the next thing I do is I set I to 0 again and J to 0 again, and this is a for to loop, which is basically like a do loop, but it does it until I is equal to 7 and J is equal to 7, and basically it just goes next until both values are equal to 7. It's pretty much the same thing we saw here, do until I is equal to 7 and do until J is equal to 7, but just another way of writing it. So then this code here is all the possible moves for a pawn. So if a chessboard ij is equal to 1, then do this function here. But if what this means is, if chessboard ij, since we've defined it at 0 and this is the first loop, this would equate to chessboard 0 0 is equal to 1. Then so what that basically does is it checks whether this value here is equal to 1, which is not, because it's a castle, so it'll be 4, but since it's not 1, it won't do this function. But if we assume it is, then it'll check if I plus 1 is smaller than 8. So if I plus 1 is smaller than 8, because if we have a pawn here and I plus 1 is not smaller than 8, then it'll go out of the chessboard. So then and if I plus 1 is smaller than 8, then another if statement, if I plus 1 comma j is equal to 0, which is if say if this is a pawn, if I plus 1, if its length plus 1, which is the piece in front of it, is equal to 0, which equates to nothing, then it can go ahead and count that as a move. So it'll the two-dimensional array here will store the value, so it'll store the first I, then the the first j, and then the I after the move, and then the j after the move. So think of these as like coordinates, just storing coordinates. So when I get to evaluating which move is the best, I can just use these coordinates to check in a loop function to check which is the best possible move. And then after that, since this is already move 0, I can now add move plus 1, so it'll become the first move, in order to make sure no moves overlap and the array keeps going on. Then I pretty much do the same thing, similar things over here, but this function here is just checking whether I is equal to 1. So whether its I is equal to 1, and what that means is it can also move 2 paces. So if I plus 1 is equal to 0, then actually there should also be a function here saying and I plus 2 is equal to 0. Then so basically if it's on 1 and I plus 1 is equal to 0 and I plus 2 is equal to 0, then you can basically move that two values. This is for cutting, so if it's less than 0, if it's a negative value which is an opponent piece, then you can cut. Similar things are done to all the other pieces like the rooks and these things. However, these are a bit more complicated because I need to use loop functions to check if the first one's free, then the second one's free, but it's a similar idea. Then the knight, that also was however easier than the rook, because the knight just has 1, 2, 3, 4, 5, 6, 7, 8 possible moves, and you can jump over pieces, so we didn't have to use loop functions to check whether the other pieces were free or not. Bishop, this was similar to the rook, because instead of just going straight and checking if all the pieces, it was just a diagonal. So I basically copied and pasted the function and just tweaked the code slightly. The queen was pretty easy because I just had to change the first line to check if it was 5, or to check if the IJ was queen, and then I can just combine the rook's moves and the rook's moves and the bishop's move together. The king also was pretty easy, similar to the pawn. But I could just move +1, and also if anything was less than 1, which if it was anything like less than 1, meaning it was either free or an opponent's piece, then it can carry out this function. There are still moves to be incorporated, such as castling and other stuff, but that can be done later after the evaluation function is made. I also need to incorporate checking and checkmating, which is much more tough than what I've done, I think. So this final function is in order to test whether my product works. It won't be there in the real final product, and what that basically does is MSG box number of moves. So when I open the program, it's gonna give me a message box with how many moves possible there are, and then dim t as an integer which is equal to 0, so just another variable, and it's going to do until t is equal to the number of moves. So since t is 0, it's not going to be the number of moves. So then it's going to print out these lines, which is basically the move t. So since t is 0, it'll be print out 0, 0, 0, 1, and then it'll just use next move as a separator, and then it'll plus t until t is equal to number of moves, so it gets every single move and it prints out every single move. So that's it for this. Now I'm gonna move into my phone and show you what the program debugs into. Now you can see we're in the camera angle, and I've got my phone here connected to the basic for Android bridge, which is also connected to the computer. If you look here, you can see we're connected wirelessly. So when I debug the program again, we should expect a message box with the number of moves, then a list view. In the list view here, telling us every single move possible in the application. So when I run the application and it compiles, I get this notification asking me to install the file. Once it's installed, I open it, and as you can see here, I get the value 53, which is the total number of moves that can be made in the chessboard according to my program. And then after I click OK, I get this list view of the different moves I can make. For example, if we look back here, since this chessboard is what I use as a test, you can see the castle is at 0-0. So here where it says the first move is castle from 0-0 to 0-1, from 0. So, and as you can see here, 0-0 to 0-1 is a move, and then it says 0-0 to 0-2, 0-0 to 0-3, 0-0 to 0-4, 0-0 to 0-5, and then it stops at 0-0 to 0-5 in its upward moves. So if you look here, that's indeed correct, because it goes 1, 2, 3, 4, 5, and then it can't move to this space because it's blocked by this pawn, but it can move to 5 since it can take out this pawn. It moves leftward 0-0 to 0-1, and 0-0, it goes all the way up to 0-2, and that is indeed correct, because it goes 0-2, it can't cut this piece because it's its own piece. So then that shows that this code works. 0-3 to 1-3, 0-3 again is this next castle, and as we've established, it does work. I can go through all these pieces, but I'm just going to pick one more piece in random to show that this program works. Here, 0-4-4 to 6-5. As you can see, 4-4 is this a knight here, and 4-4 to 6, because we're going length by width, 6-5, so that's right there. So yes, indeed, this knight can take out the pawn because it is in an L shape.